I am the Beng tutor and welcome to our channel Beng and Natural Science Tutor, where we break down tough topics into easy steps. If you are new here, hit that subscribe button so that you don't miss out on future lessons. Let's dive in. For today, we are going to look at question D, Roman numeral 1. For vector valued function pt, where pt is equal to 4 over 5t minus 3I for the x perimeter plus t exponential to the power t j for the y perimeter plus 4 over root of 4 minus t squared k. Now what are we required to do? We are required to compute the integral of pt. The integral of pt. Now, how we are going to approach this question is, we are going to be solving each perimeter on its own. Then at the end, we are going to add all the answers we are going to get the final answer. So let's start. Let's dive in. Let's start. What's the perimeter for x? The perimeter for x is 4 over 5t minus 3. So we are going to integrate it individually. 4 over 5t minus 3. Minus 3. Now, let's try to analyze this on how we can integrate it. If we look at the bottom, the degree of t is t to the degree of 1. Meaning if you assign the bottom part to equal to u, when you differentiate finding du, there is no we are going to find that the t will disappear. So we can eliminate all the t values from this equation, from this expression, and take it into the u world. So let's say u is equal to 5t minus 3. Then du is the same as 5, isn't it? Because when you differentiate a constant, we are going to get a constant. When you differentiate 5t, we are going to find 5 dt. So this is the same as that. So now we are going to make dt the subject of the formula. So dt is equal to du over 5, isn't it? Now let's write that bad boy the way it is. It has 4. Then we're going to change at the bottom. What is 5t minus 3? That is what? U. So I'm going to write u. What is dt? Dt is du over 5, isn't it? So this is the same as, we're taking out the numbers. So du over u. Now if you look at this, these are one of the already solved integrals out there. They are already given even in books. 1 over u or 1 over x, when you integrate it, you're going to get the natural log of u or natural log of x. So du over u, when we integrate this, we are going to get ln of u. So what was u? U was 5t minus 3. So for the first part we are done. We have to go to the second perimeter, which is t e to the power t j, the perimeter for y. So we integrate it individually as well. So the integral of t e to the power t dt. Now when you look at this, it is a product of two functions. When it's a product of two functions, we are going to use integration by parts. Integration by parts says this: u dv is the same as uv minus integral of v du. Now when you look at this tells you that it is for this form. So for this form, it means for that guy we only have what? U and dv. We only have u and dv. So it will require us to find v and du. So how can we assign which one is u and which one is dv? There is this lovely way. I don't know how you call it, but for me I love calling it Liate. Yeah, Liate. This bad boy here, L stands for logarithmic function. I stands for inverse function. A stands for algebraic function. T trigonometric function. E exponential function. So now if you look at this, what family member here does t fall into and e to the power t fall into? Now if you look at t falls in algebraic function, then e exponential falls here. So whichever appears first, that will be your u. Whichever you appear first, that will be your u. So what appears first is algebraic to exponential. Now which one is algebraic there? It is t, isn't it? So t, that's the one we are going to get as our u. So u is equal to t. Then dv is equal to exponential t, isn't it? So now when we differentiate u to find du, we are going to get 1 dt, isn't it? When we integrate dv to find v, when we integrate it e to the power t, it's the same as just writing it as itself, because it doesn't change. So now you have u, you have du, you have dv, you have v. The first thing is v multiplied by u. Then subtract the integral of v multiplied by du. So let's write that. So what is our u? Our u is t. What is our v? Our v is e to the power t minus this one v. Now what is our du? Our du is the same as just what? Dt. So now look at this. We have to just integrate one function now. So it will be t e t, then minus. What is the integral of et? The integral of et is the same as just et itself plus c. And here we should have added a plus c, a constant, since we were integrating. So we have found for the x perimeter, for the y perimeter. Now we have to find for the z perimeter. For the z perimeter, what is our z perimeter? Our z perimeter, it is it is 4 over root of 4 minus t squared. We have to integrate this boy. Now let's try to analyze which method of integration can we use. Look at this. Even if we assign our bottom part to be equals to u, when we differentiate, we are still going to remain with a t. But our main aim, if we were to use what? If we were to use the u substitution method, we have to eliminate all the t values from this expression. So now, looking at this, we can try to relate it to trigonometric function. Since we have a t squared at the bottom and no t value on top, the only way which is more suitable to use for this is to use trigonometric substitution. Now we have to ask ourselves, which trig substitution is suitable for this bad boy? Which trig substitution is suitable for this bad boy? Now when you let me show you here. When you find something like 1 over 1 plus t squared, whenever it's a plus, even if it's the root of 1 plus t squared, your t will equal to, let me put this as a squared. Your t will equal to a tan theta. When you find something like 1 over t squared minus a squared, like this, where it is just t squared minus a squared, your t will equal to a sec theta. When you find a scenario where it is a squared minus t squared, like this, requiring you to, and you're being required to integrate. For this, your t will equal to a sine theta. These are the most basic, the three most basic ways. So let's analyze here. When you look at this and you look at this, it is similar. Now, but it is saying a squared. Now we have to identify what a is, isn't it? So now, if a squared is equals to, if a squared is equals to 4, a is the same as root this side, root this side. So the root and 2 will cancel. Now what is the root of 4? The root of 4 is 2. So a is equals to 2. So t is the same as 2 sine theta, isn't it? Now what is dt? Dt is the same as 2 cos theta, isn't it? Now let's substitute what we have. This, I'm going to have 4 there. I'm going to have 4 minus 2 sine theta squared. Now what is my dt? Dt is the same as 2 d theta, 2 cos theta d theta. So now this is where I am now. This is what I have. Now let's come and work with the bottom. Let me write the top part as it is. 2 times 4. Let me just put 8 here. Then cos theta d theta over. Now let's come to the bottom function. This is 4 minus, what is 2 squared? 2 squared is 4. Sine squared, you see, sine squared, the way it is. Now look, this 4, we have a 4 here and we have a 4 here for this function. So we can factor out a 4. Let's do step by step. Let's write the top function the way it is. And let's factor out a 4. We're going to remain with a 1 here. Then we're going to remain with the sine squared theta, isn't it? Now, what is the root of 4? The root of 4 is what? Is 2. So what we are going to get in the next step is cos theta d theta divided by 2, isn't it? Root of 1 minus sine squared theta. Now, this bad boy here is an identity. Where is it coming from? Let me show you. Cos squared theta plus sine squared theta is the same as 1. Now what is sine squared theta? Sine squared theta is the same as 1 minus cos squared theta. Now what is cos squared theta? Cos squared theta is the same as 1 minus sine squared theta. So now we know what cos squared theta is, sine squared theta is. Then we know cos squared plus sine squared is equals to what? 1. Now let's check. We're having 1 minus sine squared theta. Now what is 1 minus sine squared theta? It's the same as cos squared theta. So we're just going to replace inside the root cos squared theta instead of 1 minus sine squared theta. So let's rewrite everything. What is 8 divided by 2, that is 4. I'll write it outside. I have cos theta, d theta on top. Then I have root of cos squared theta. Now we'll write what's on top. Now, what is the root of cos squared theta? Root of cos squared theta is the same as cos. So we have cos on top and cos at the bottom of the fraction. Now, what is cos divided by cos? Our final expression, we're going to have d theta alone. Now we are integrating d theta. Now, what is the integral of d theta? It's the same as the integral of dx. So the integral of d theta is theta. The integral of dx is x. So we're going to get 4 theta plus c as our answer. Now the only question is what is theta? What is theta? So the way we can find theta, we have to go back. T was equals to 2 sine theta. We can make theta a subject here. So we can come here. T is equals to 2 sine theta. So how can we make theta a subject? We can start by saying theta is equals to okay, let's do it step by step. Sine theta is equals to t divided by 2. Now what is theta? Theta is the same as the inverse of t divided by 2. We first started by dividing a 2 both sides. So these 2 will go here. We are going to have t divided by 2. Now we are having when we shift a trigonometric function from the other side to the other side, it becomes inverse. It's more like it becomes inverse. So theta is the same as sine inverse t squared. So where there is theta here, we're just going to replace with that. So it is going to be 4 sine inverse t divided by 2 plus c. Now remember, you have to remember all our answers. Let's go and check for all our answers, what we found for all answers we were solving. So for the first part, we got this. For the second part, we got this, which is the first part, the second part. For the third part, that's what we are from solving. We got this. Now we have to add them all. That is our answer. We just need to add them all. That will be our answer. So let's write our final answer. Our final answer is going to be 4 over 5 ln of 5t minus 3, then plus this guy t exponential t e exponential t, plus go to the other side. Check, we have 4 sine inverse t over 2 plus 4 sine inverse t over 2, then all of these plus c. So this will be our final answer for the integral. This will be our final answer for the integral. So this is the same. Let's put since there are parameters, let's put these. Yeah, this will be our final answer. Thank you for watching. We hope on seeing you back.